Today we will be discussing about the creation of mesh for the two cylinders with the different diameters. So to create the cylinder, I would use the built-in function in the ICEM CFD, but I would need 2 points as access points. So let's create the access points. So the first point is at 0, 0, 0. Second point for the bigger cylinder is at the Z is equal to 5. Units are meters. So you can view in the left, and the last point is at the Z is equal to 10 over here. Now we will go inside the surface tool, and inside the surface tool we have the detailed view about the surface tools, and you can see there are the 3 rows, and in the last row, third row, the last option is about the standard shapes. So from standard shapes you can choose a cube or a sphere or the cylinder, and there are other options also, but we will choose the cylinder. And as a radius, I will put here the point 1, and also on the other side the point 1, because I want to make the cylinder in a straight line, and I am not considering any tapered cylinder here. That's why the both sides have the same radius. And I will choose the 2 axis points I have just made here. So choose these 2 points and click on the middle mouse button to create the cylinder. Second cylinder is a bit bigger in the radius as compared to this cylinder. So I would put the point 2 and the point 2. It means that the diameter is 0.4 meters. So I will choose these 2 points. You can from here click on to make it solid. So now we have the 2 cylinders having a diameter of the 0.4 and the 0.2 meters. Because we are going to create the Hexa mesh, so I will use the blocking, and the first thing in the blocking tab is we create the one single block and put the name here as the fluid, and the option on the default is a 3D bounding box. Click on apply. This will create a one block, and now our task is to fit this block on this geometry. So you can see that it's fitting very nicely on the bigger cylinder, but it's a bigger than this small diameter cylinder here. So we need to adjust the blocking. For this, first thing is that we will split the block at the location where the geometry is transiting from the one shape to the other shape. So from smaller to bigger, or bigger to the smaller diameter pipe. For this we need to split the block at this location. So we will use the third option in the blocking sub tab, that is a split block. and the first option is about the splitting the block, and the block select is visible. And in the split method, before choosing the any edge where we want to make a split, change the method to the prescribed point. So prescribed point basically will give us a location exactly at the location where the geometry is transiting. Now choose the edge. So any one of the 4 edges will do the work. So you can choose any edge, and this should work. So any edge will work, and I will choose the point here. This has splitted the block at this location. The next thing is to make the blocking fit to the smaller diameter cylinder. So again, in the splitting in the split block command, the second option is the method is the O-grid block. This is used to create the O-grids, but this can be used to basically get the shape about for this geometry. So we'll use this command and choose both the blocks and choose 2 faces on the extreme ends of these 2 blocks and click on apply. This will basically create the O-grid inside the both blocks, and we have the 2 benefits here. One is that it has O-grid for the bigger block, and the second benefit is that we have got the blocks for the small cylinder, and since these blocks are on the sides, these 4 blocks are not needed for this small cylinder, so we have to delete these 4 blocks because they don't correspond to any geometry here. Okay, next thing is to associate the edges to the corresponding curves. So hide the surfaces here, and on the blocking, click on the right mouse button and choose the option index control, and from the O3, click on the upward arrow to make the index is equal to 1. So as you can see, the outer blocks are now hidden from the view. Now you can select the edges to associate them very easily for the small diameter. So just do it on the other side also. Now you can make the blocks visible for the bigger side, and again associate the edges to the corresponding curve. So just use the 4 edges and then press the middle mouse button. For selection, you have to use the left mouse button. So choose them 4 in a row, and then press the middle mouse button to confirm the selection. Then it will go into the curve selection, and then choose this curve on the circumference of this bigger cylinder, and then again press the middle mouse button. To confirm that the edges are associated to the curve, the first thing you notice is that the color is turned to the green. And second thing you can see is if you right click on the edges and then click on show association, they will point towards this curve. This means that these edges are associated to this curve. So is confirmation that we have done the association in a very right manner. You can click on reset to show all the blocks again. Now you can see that these blocks are outside the geometry. So to make them nicely fit to the geometry, we can use the snap vertices Synapse project vertices command and click on apply. Okay. The next thing is that you can see that the smaller block has some different shape on the both sides. So because that when we adjusted the block, all the vertices move towards these curves. But here, since we don't have any curves here, so these four edges didn't move to any location. So to make them in the line, we can use the move vertices command. And from move vertices command, we will use the third option, which is align vertices. So just we need to choose one edge on the small cylinder and then corresponding vertex here. So if we choose this edge, then we have to choose this vertex here and then click on align. This will align all the edges on this side also. So you can undo it and just check that what is happening there. Let me choose the edge and the corresponding vertex. Now I'm just placing this this vertex on this edge of this window. So just to show you that whether they are moving or not. So just click on apply. You can notice that the four vertices are moved inside the geometry. So now they have the almost equal shape and length on all the sides. The next thing is to create the O grid for the small cylinder. So again we have to choose all the blocks. Before that, hide the block on the outer side of this block, which is on the bigger cylinder, and then choose these two blocks and the two end faces on the extreme side and click on apply. Now we are set to go. Now we need to set the pre-mesh parameters. So just first thing is that right click on the edges and just uncheck the show station. It is making some confusion. And the next thing is to hide the curves and points. Now we just have these edges. Now we can choose any edge and just put here 10 nodes here and just copy parameters to the all parallel edges. Just enable this option. Here also 10 points. On the diagonal edge, we are just putting again the 10 points here. On the length of these two cylinders, just make them the 40. And then on the diagonal edge for the bigger cylinder, I'll put the 10 points. Now click on the pre-mesh to see how the mesh will look like, and click on the solid. This is how the mesh will look like. This is pretty fine mesh. You can change the grading towards the wall so that we can resolve the velocity or pressure gradient nicely. So you can see that the arrow is pointing towards here. So this is the starting point and this is the ending point. So this is the tail of this arrow and this is the head of this arrow. So the tail side is the side 1 and the head side of the arrow is the side 2. So it means that we need to set the parameters on the tail side of this arrow, which is side 1. So on the side 1, right now the size is 0.006. This is the size which is decided by the ICEM CFD itself. So I will just make it 0.005, and the ratio, which is how the mesh will grade from the first cell to second cell, how it will grow from this first size to the second size. So if the first cell size is the 0.005, the second size will be the 0.005 into the 1.2 times. Just click on apply and right click on pre-mesh and recompute, and this is how the mesh will look like. Here you can put the more points in the O-grid and right click and on the pre-mesh and recompute. Okay, so this looks nice to me. Similarly, over here we can change the grading. So here I will put again 20 points, but this time I will put the point 000 on the both sides, because I need to match the grading also on the small cylinder, so the grading should be similar. So it's the 1.2.005 and the 1.2. Apply and I click on pre-mesh and recompute. Make the nodes equal to 20 and again right click on pre-mesh and recompute. This is how the mesh is done for this geometry. You can right click on the pre-mesh and convert the mesh to the unstructured mesh, and from the output mesh you can set a solver. So default solver is the Ansys Fluent. Click and apply. You can set the boundary condition if you want to, and but for that thing you need to define the parts. So let's say I have the parts. Let me call them this part on smaller cylinder. Let's say this is the inlet. This is the wall between two cylinders. This is the wall of the small cylinder. This is the wall of the big cylinder. Okay. And here I have the, let's say, outlet. So it means we have the boundaries like outlet, wall of the big cylinder, then we have the wall between, and then we have the wall on the small cylinder and the inlet. This does not count to anything because on the both sides we have fluid, so there's going to be no mesh on this wall. So just because in the ICEM CFD it does not care about these internal walls unless we specify them explicitly. So it will not take any effect and this will not be outputted as a mesh. So don't worry about this thing. Again calculate the pre-mesh and then again convert to the unstructured mesh. Now you can set the boundary conditions after defining the parts. In the surfaces, let's say on the inlet I will put the boundary type as a velocity inlet. On the outlet I will put the pressure outlet. It is your choice, you can choose any boundary. On the wall boundary condition is the wall big cylinder, so it's a wall. You can copy this boundary condition and then you put the same on this other wall here, and on the wall small cylinder you can paste it, also paste it over here. And let's save this project as two cylinders. Okay, and the last step is to write the input file or to export the mesh. Click on yes, open this unstructured ICEM CFD mesh file, and you can change the default name from Fluent to some other name which is meaningful. So let's say it's a two cylinders. Okay, click on done. I will open the Fluent and I will point to the, let's say, the D drive where I have stored the mesh file. I think we have stored the file in the D drive. Let me check it. Yes. This file over here, two cylinders.msh, which is the extension for the Fluent. Okay, now choose a 3D dimension and the serial, uncheck the double precision. We don't need this thing right now because we are just checking the mesh inside the fluid. We will not run the case here. So just blocking tutorial, and I just want to check the mesh, that how it look like, and the quality of the mesh from the ICEM CFD. So locate the 2-cylinder mesh file and open it. Display the mesh. You can uncheck the faces to just display the wireframe, and it looks nice here. Okay, thank you for watching this tutorial. See you next time. Bye bye.